Welcome to this presentation given by Applied Scientific Technologies. We are a UK company that specialises in laboratory digitalization and robotics. My name is Dr. Dale Charlton, and I shall be your guide for the presentation. The presentation is part of an online virtual conference in 2020 given by the SiLA organisation, and we thank the SiLA organisation for an opportunity to present here. The title, To SiLA or Not to SiLA, that is the question, is an obvious spin from the Shakespeare play Hamlet, to be or not to be. And we're using this in the context of alluding to the use of SiLA in laboratory digitalization and automation environments. Today, Applied Scientific Technologies make extensive use of the SiLA 2 standard. And this presentation aims to show the viewer where Applied Scientific Technologies use SiLA and why, using our laboratory digital product we call Deft, which is the Digital Enabled Formulation Toolset. So before diving into the details of the Deft product itself, perhaps a short history. Deft was developed with a FTSE 100 global consumer products company in response to a need and what they felt was a genuine gap or lack of choice regarding laboratory instrument connectivity. And despite the much vaunted interest in digitalization, there are still not very many products available at the bench level to integrate and control laboratory instruments together in any form of network. Most current digital products in this space tend to be the high-level software solutions like LIMS, electronic lab notebooks, chromatography data systems, and instrument communication protocols. With many of these high-level software systems still rely on proprietary software and some kind of formal arrangement from the LIMS or the electronic notebook companies to write bespoke software. So the fact today is many common bench laboratory instruments such as pH meters, stirrers, heater shakers, centrifuges, pumps, circulation vats, etc. Most of these are still not connected and are standalone. We also recognize that most current lab digital products are focused much more on the pharma and biotech industries. And our customers are telling us that a lot of these are not necessarily a particularly good fit for chemistry and consumer products formulation laboratories. So our aim was to develop a digital product and service that would also be suited to the formulation R&D labs of chemicals companies, things like paints, oils, inks, mining industry, hair care, sunscreen with regards to consumer products, as well as food and beverage. So looking at the Deft setup itself for the Deft platform, we describe it as a scalable bench level network of connected laboratory instruments, all controlled via a formulations app. Currently, there are over 20 SiLA drivers developed for a whole range of common laboratory instruments. The Deft itself is composed of a number of components. This includes the Deft gateway, which is the beating heart of the system, and it's on the gateway that we have the SiLA rapid integration instrument drivers located. The gateway is Wi-Fi and Bluetooth enabled also, and it has a UPS data backup system to ensure that even if experiments are running overnight or over several days, that we don't lose important data. The other component part, or one of the other component parts, is the instrument ID tags, and this essentially is a matchbox size electronic box that holds a unique identifier, a QR code, a barcode, for the actual instrument to identify the instrument itself to the network, and some onboard software and electronics to convert instrument commands into Bluetooth protocol. And on that basis, it obviously plugs directly into the back of the instrument via the comms port. The data site manager essentially collates all the data from the various sources, LIMS, host network, the Deft gateways themselves, and makes this records the data and makes this data available over the network via the Wi-Fi protocol. And the Wi-Fi router is just what it is, a Wi-Fi router. There is also extensive end-to-end encryption. So if allowed, in-house networks can be connected to the cloud for remote access and fault finding, as well as asset management applications. For example, is the instrument online? Is it broken? Does it need calibration? Does it need electrical safety test? All of that information can be viewed via user-inspired dashboards and monitored via key performance indicators, all of which is described in the highly stylized diagram, where you see all the instruments surrounded by a cloud, which is Bluetooth, and that Bluetooth is then communicating backwards and forwards to the Deft gateway. The Deft gateway is also Wi-Fi enabled, and that can connect to the wider Wi-Fi network into the cloud if necessary. And all of that is controlled via an app which communicates to the Deft gateway. So what does the Deft system actually look like? And what we have here is a picture with all the components listed, as well as, in this case, 3 classic common laboratory instruments. We've got an ICA Eurostar stirrer with temperature probe. We have an O-house balance for maybe you're dispensing powders to weight and adding to a reactor vessel or some kind of beaker. And then to the right of that, we've got an Integra Biosciences via flow electronic Bluetooth enabled pipetter. And indeed, that's what we see in the future. We're starting to see a number of instruments with onboard Bluetooth connectivity. And that does make life a little bit easier insofar as the Integra Bluetooth enabled pipetter doesn't need the ID tag. In the top left-hand corner of the ICA stirrer, you see the side of the ICA stirrer and you see an ID tag. And this ID tag has 2 cables running from it. One of those cables connects to the comms port on the ICA stirrer, and the second one is simply a power supply. So if we move back down to the right-hand side now of the picture, you can see that the blue box next to the Integra pipetter is the site data manager. You get an impression of its size. And next to that is a classic-looking Wi-Fi router. Draw your attention to the white box in the middle, and this is made of corin, so it's resistant to typical lab chemicals that you might find on the bench in case of spillages, etc. But this is actually the Deft gateway, and this is where the SiLA rapid integration drivers reside. In the following slide, you have a little bit more of a description of the Deft system.
So the Deft we have in front of us is a 4 gateway device, so we can connect 4 instruments. Within the Deft, it's communicating via the Bluetooth to the instruments, and then the Deft box uses a little bit of programming to change the information into the SiLA protocol, which then allows it to communicate with the software in the app. Now, by doing this, it allows us to change the different manufacturers' devices or instruments, sort of almost to a plug-and-play standard at the moment. As things develop and we see more and more SiLA protocols being added to instruments, like I say, we'll be able to interface directly into them via the app. The box also has built-in UPSs, so if there is a power failure, etc., it will store the data, it'll keep coming, and you can either put it in a safe shutdown and store the data without losing the information required. And also the system uses end-to-end encryption, so it keeps all the data safe. So obviously security is a big issue, and then depending on how you're doing it and what you want, sending the data either, like I say, into a local storage device or up into.
I think one of the questions to ask is, why did we choose to adopt SiLA 2 into our Deft products? And without it, it would be very difficult to function in the way it does. I think one of the key drivers here for us is that we see that the SiLA organization is a not-for-profit organization, and any money or any revenue that it brings in, that money is reinvested back into the product itself to broaden its appeal. So I think that's an important point. It's becoming an industry accepted standard, and certainly we're beginning to see a lot more interest from some of our prospective customers. So we offer B2B services to lab instrument manufacturers, and we certainly see a number of them taking far more interest in both the Deft product and in the SiLA communication protocols themselves. So we think there is a momentum gathering, which was hitherto possibly not there. The other aspect for us, of course, is that we can connect almost any instrument as long as it's got a comms port, and so we can handle legacy equipment as well. And that's quite important because, of course, a lot of laboratories that we function have got equipment hanging around and they've been using for years, and wherever possible, they don't necessarily like to or need to invest in new lab instruments. So for us, this is a big win, and it allows rapid and quick integration of new instruments. If the SiLA driver is available and we can get them from the SiLA website, or we've developed them ourselves, or instrument manufacturers develop them and they can offer them, then we really can integrate new instruments into the Deft product in a relatively short space of time. And that what we're talking about there really is literally a matter of days or a week or so. And most of that effort is actually building the communication protocols for the app so that we can control the instrument and build it into a integrated network. The scalability of SiLA with the Deft really is unparalleled. It's a huge asset for us. So in order to enhance the network, you can just buy or take more Deft gateways. And so it's virtually unlimited expandability. So currently we're up to around 200 and 250 instruments on a single site data manager network. You just keep adding new gateways and in turn new instruments to those gateways. So the modularity and versatility is there, and it's highly adaptable, and it suits our purposes. And quite honestly, there are not many real alternatives out there, and we certainly didn't want to develop a proprietary software tool set ourselves, which just added to the difficulties of communicating to lab instruments. So the fact that there is a standard out there and that standard is gathering momentum and people are beginning to recognize the value of it is a real asset for us. And quite frankly, we haven't seen anybody out there as structured, as organized as SiLA for a non-profit organization. So we're quite happy to base our product around the SiLA standard, and hopefully we can continue to do that and move forward. So a small note about the Deft app itself. It's downloadable onto any Android or iOS device, such as mobile phone and tablet. It's fully CFR 21.11 compliant, with several levels of user, from expert down to operator. And it comes with LIMS connectivity. It's pretty much standard. Most of the common LIMS available in analytical laboratories are known to the system. The Deft app acts like a digital logbook. You can make notes, take photos, record videos, and the formulation icon within the app allows you to build up experimental design and experimental protocols by adding functions such as stir speed, time, heat and cool to temperature, so maintain a fixed temperature, for example, or vary that temperature over time. You can monitor viscosity, pH, conductivities, and a whole range of other classic laboratory processes. So it really brings us to the end of the presentation. The Deft is a scalable bench-level network of connected laboratory instruments and control app, one of very, very few products out there. We currently already have over 20 SiLA 2 driver protocols already developed. Without SiLA, this kind of approach would take much, much longer, cost far more, and would be far less flexible. And without SiLA, Deft would simply not be, and laboratories would continue to suffer the slings and arrows of outrageous misfortune, excuse the pun. Deft comes as a family of products, a standard 4 gateway instrument, and the starter pack, which is 1 or 2 instrument gateways. And in Q1 2021, we'll launch the Deft reactor product to manage and control formulation reactors, benchtop reactors. Thank you very much for your time.